Good morning, all. This is Swetha. I hope you all are doing great today. Today, we are going to discuss about ring homomorphism, which is a part of algebra. In today's topic, these are the contents: ring homomorphism, ring isomorphism, kernel of ring homomorphism, properties of ring homomorphism, fundamental theorem of ring homomorphism. We'll know about these contents in detail in your further slides. Now moving to your next slide. Ring homomorphism. Homomorphism is the function which preserves the group operations from one group to another group. So the same thing will be applied even for the ring theory. Okay. So the ring homomorphism phi forms from the ring capital R to the ring R dash with respect to sum and the product from the mapping R to R dash, preserving your two ring operations. Okay, that is phi of a plus b equals to phi of a plus of phi of b, and your second one phi of ab equals to phi of a dot phi of b. It means all the elements in your ring R will be mapping to your ring R dash. Okay, so if these two properties are satisfying, that is when the mapping takes place between the two rings under these two conditions, then we say that as your ring homomorphism. Okay, now we'll move to your next topic, ring isomorphism. Okay, a ring homomorphism which is both 1 1 and the onto, that is any ring homomorphism when it is containing both your 1 1 and onto, then we say it as your ring isomorphism. Hope it's clear. Now we'll move to your next slide. Kernel of ring homomorphism. So you already know the kernel of ring homomorphism part, which you have already learnt in group theory. So the kernel of homomorphisms are nothing but ideals, right? So we define the kernel as, let phi from the ring R to S be a ring homomorphism, then the collection of all the elements of R such that the image of the elements is 0, then this image will belong to S. I hope it's clear. Collection of elements of R such that image all are here 0, then image belongs to S. So obviously the 0 belongs to the S. In this way we define your kernel of ring homomorphism, and we denote it with the curl phi. Okay, and your next topic is properties of ring homomorphism. In a properties of ring homomorphism, we consider capital R and capital S be your two rings with respect to your two elements 0 and 0 dash, where both belong to your ring R and the S respectively. Then following are your 5 properties which will be used to solve the problems, or whereas we required for proving the theorems also we use these properties. The same properties can also be expected as the question in your exams. Okay, now we'll move to your last slide. Fundamental theorem of ring homomorphism, one of your important theorem and named theorem. We also call this theorem as the first isomorphism theorem. It states that phi is your ring homomorphism from capital R to S, then the mapping, that is phi mapping from R by A to phi of R, is an isomorphism. It means that when capital R by A is isomorphic to phi of R, then we say that the fundamental theorem of ring homomorphism holds, where your capital A is your kernel of phi. Okay, to prove that R by A is isomorphic to phi of R, we require three conditions. One is your phi should be well defined function, phi should be your isomorphism, and phi should be a homomorphism. If these three conditions are holding, then we can say that R by A is isomorphic to phi of R. Okay, hope it's clear. Thank you all for listening to this topic. If you have any queries, please do reach me. We'll keep working forward. Thank you once again.